You'll never ever get your head around how big the universe is. Don't go there. It's just vast. It's enormous. There's no way the human mind, I think, can actually comprehend the true immensity of the universe. We're happy with the size of an elephant or the size of a tree, or maybe even the size of Durham Cathedral. But I think if we go beyond that, then our brains just start to run out of gas. It may be difficult for our brains to comprehend, but that hasn't stopped astronomers endeavoring to measure the distance to the stars. One technique is to use a phenomenon called parallax. Everybody can actually experience parallax for themselves. If you hold your thumb up and close one eye, you can see that your thumb appears to be in a certain position relative to something behind your thumb. But then if you open that eye and close the other eye, you'll see your thumb appears to move relative to the object behind. The same thing happens when we look at the stars. When we look at a relatively nearby star from the Earth, it appears in a certain position relative to the other background stars. 6 months later, when the Earth is on the opposite side of the Sun, the same star will appear in a different position relative to the background. Like opening and closing one eye then the other, the star appears to move. And by measuring this apparent movement, we can calculate the true position of the star. An alternative method of measurement is to use certain stars in the sky known as standard candles. We know exactly how brightly they shine. If we can therefore measure how bright they appear to us on Earth, we can calculate how far away they are. The dimmer they appear, the further they are from the Earth. So the nearest star to the Sun is Proxima Centauri. And that, it turns out, is 40 trillion kilometers away. That's 40 million kilometers away from the Earth. Such numbers start to become incomprehensible, and that's why astronomers have adopted an alternative unit of measurement for such vast distances, the light year. A light year is the distance that light will travel in 1 year. If you imagine light moving around the Earth in 1 second, in that time, light would travel around the Earth over 7 times, so that's fast. The speed of light is 300,000 kilometers a second, so 1 light year is about 9 million kilometers. The speed of light also leads to a curious consequence when we stare at the stars. The light from the Sun takes 8 minutes to get to the Earth. That essentially means we're looking into the past. We're looking back at the Sun as it was 8 minutes ago. If the Sun was to disappear right now, we wouldn't know for 8 minutes. So a telescope, if you like, is a time machine. We're looking back in time, and the further the object is away from us, the further back in time we're seeing it. Our Sun, like nearly all the stars we can see with the naked eye, sits inside the galaxy we call the Milky Way. But our galaxy is not alone in the universe. Not everything you can see in the night sky is actually in our galaxy. It turns out that some of those faint dots are, in fact, other galaxies. The furthest object you can see with the unaided eye is another galaxy called Andromeda. The light from that galaxy has taken something like 2.25 million years to get to the Earth. So if you imagine if we reverse the scenario and you're looking at the Earth from Andromeda with a very powerful telescope, you'd see no signs of cities, no civilization, no Great Wall of China. You might be lucky enough to see 1 or 2 early humans hunting around on the African plains for their dinner. Astronomers have always wanted to see further, using bigger and better telescopes to try and find out just how many other galaxies are out there. Until finally, we pointed the Hubble telescope at what at first appeared to be a very dark and ordinary patch of the night sky. If you imagine holding up your finger with a grain of sand on it and looking at the patch of sky that grain of sand blocks out, that's the field that the telescope zoomed in onto. And what the telescope saw was incredible. Every single speck of light in this photo is a galaxy. 10,000 galaxies in a patch of sky the size of a grain of sand held at arm's length. If this tiny patch of sky is like every other, then we can calculate how many galaxies are out there. The visible universe contains around 100 billion galaxies. Each one of those galaxies contains around about 100 billion stars. That means the visible universe contains something like 10,000 million stars. That means there are more stars in the visible universe than there are grains of sand on the Earth. The light from some of these most distant galaxies has taken around 13 billion years to get here. That's light traveling at 300,000 kilometers a second. The visible universe stretches around 13 billion light years from the Earth. So we've said the universe is big. I'm going to try and give you some idea how big. Imagine the Earth as a grain of sand. If that was the case, then our solar system out to the orbit of the planet Neptune would be as big as Durham Cathedral. So now let's imagine we take our solar system and we shrink it down to the size of this grain of sand. Then our galaxy, the Milky Way, would be 1,000 times bigger than this cathedral. So now we take the Milky Way galaxy and shrink it down to the size of the grain of sand. The cathedral would be the entire visible universe. The universe is big, it's really big.